So we are now in transformer on load. So here is our equivalent circuit in our previous discussion. For us to solve the parameters here easily, we need to get the approximate circuit diagram, which is referred to primary or secondary. So in order to analyze the transformer, we can transform all the parameters to either primary or secondary of transformer. It is called the equivalent circuit referred to primary side or secondary side. So here, in our primary side, I/O or the no load current is very low. So we will consider it the I/O PC. PC is copper loss due to the resistance here, and IM due to the magnetization. So we will consider all of this to be equal to 0. So mawawala na tong circuit dito. So equivalent approximate circuit diagram of a single phase transformer, we will transform either in primary or secondary. So first we will go to the referred to primary. So all of our parameters, the resistance, inductances, will be transferred to primary. So the circuit will be look like this. We have R1E, Rx1E. So R1E is the equivalent resistance referred to primary. X1E is the equivalent reactance referred to primary. So R1E is equal to R1 plus R2 multiplied by the number of turns at primary divided by number of turns at secondary squared. Same in X1E is equal to X1 plus X2 multiplied by N1 over N2 squared. N is the number of turns. So V1, our input voltage, will be equal to A, the transformation ratio, times V2, the output voltage, plus I1 Z1E. So Z1E is R1E plus JX1E. So total resistance voltage drop referred to primary, we have voltage drop 1 is equal to current at primary I1, R1 plus A is the transformation ratio, I2, R2. Where your A is equal to I2 over I1, so therefore I2 is equal to A, I1. Substitute this one into our equation. It will be I1 R1 plus A times A I1 R2. So it will become I1 R1 plus A squared I1 R2. Simplifying that, we will come up with VD1 is equal to I1 times R1 plus A squared R2. Referred to secondary, so we have our induced voltage here as the main source of secondary transformer. So R2E is the secondary resistance equivalent, X2E is the equivalent reactance at secondary, and ZL the load impedance. This is our output voltage V2. So R2E is equal to R2 plus R1 multiplied by N2 over N1 squared. So X2E is equal to X2 plus X1 multiplied by N2 over N1 squared. Total voltage drop, we have I2 R2 plus I1 R1 over A. So I1 is I2 over A. So I2 R2 plus I2 R1 all over A squared. We will substitute this one here. Therefore, the voltage drop at secondary is equal to I2 times R2 plus R1 over A squared. So we will have an example. A transformer is rated at 2,300 at the primary and 230 at the secondary volts, 15 kVA and 60 Hz. We have number of turns in primary 1,500, at secondary is 150 turns, R1 2.7 ohms, X1 9.1 ohms, R2 is 0.024 ohms, X2 is 0.088 ohm. Determine the voltage regulation, assuming that the transformer is operated at 80%, power factor lagging at rated output. The secondary terminal voltage is 230 volts. First, we will define what is a voltage regulation. So voltage regulation is the voltage change between the full load and no load divided by the full load voltage. So percent voltage regulation is equal to the output voltage at no load minus the output voltage at full load divided by the output voltage at full load times 100%. Or the input voltage at primary divided by the transformation ratio A minus the output voltage at full load divided by output voltage at full load. So V2NL is the secondary no load voltage, V2 is the secondary full load voltage, and V1 is the applied voltage. So going back to our problem, we will list all the given parameters. So we have our A transformation ratio is equal to N1 all over N2. That is 1,500 divided by 150 turns. So that is 10. We have a power factor equal to 80% or 80% lagging, or 0.8 lagging. Our rated output is the V2FL is equal to 230 volts. Primary voltage is 2,300 and our apparent power is 15. Before we can solve the voltage regulation, we need to solve first the equivalent resistances at primary and equivalent reactance at primary. Okay, so RE1, so our working equation will be percent voltage regulation equal to V1 over A minus V2 full load divided by V2 full load times 100. From our formula, this one, V1 over A minus V2 full load divided by V2 full load. So V1, we can solve V1 equal to A V2 plus I1 JE1. From our formula a while ago in the primary, nasan na yun? So this one, V1 is equal to AV2 plus I1 JE1. So JE1, para makuha natin yung JE1, kailangan natin ng RE1 and XE1. Also, we can solve I1 by our apparent power S equal to EI. Okay? So given na yung V2, na-solve na natin yung A. We can solve current by the formula apparent power is equal to EI. So I is equal to S over E. S is 15 kVA divided by the primary voltage. Since this is primary current, so primary voltage 2300, that is equal to 6.522. The angle is, since this is a lagging power factor, our theta is the arc cosine of 0.8. That is 36.87. Lagging, so negative 36.87 degrees amperes. Solving now the RE1 and XE1. So RE1 is equal to R1 plus R2 times N1 over N2 squared. So that is 2.7 plus 0.024. N1 over N2 is 10 squared, equal to 5.1 ohms. XE2 is XE1. So X1 plus X2 N1 over N2 squared. So 9.1 plus 0.088 10 squared, equal to 17.8 ohms. Therefore, our impedance now will be equal to JE1 5.1 plus J 17.8 ohms. V1 will be equal to A V2 plus I1 JE1 equal to A is 10 times 230. Our full load output voltage at secondary, angle 0, plus I1 is 6.522, angle negative 36.87, times our impedance 5.1 plus J 17.8. So V1 is equal to, so that is, lagyan natin ng bracket, 2,397.369, angle 1.743 degrees volts. Percent VR is equal to V1 over A minus V2 full load divided by V2 full load times 100. So magnitude only, 2,397.369 minus 230 divided by 230. So divided by 10 pala, times 100. So percent VR is equal to 4.233%.